So let's talk about the quadratic formula. The solutions of a quadratic equation in standard form are given by the quadratic formula. This is something that you will have to memorize if you want to use it. That is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You can sing this to Pop Goes the Weasel. I'm pretty sure I have a video of me singing this on my TikTok. You are welcome in advance. So let's go ahead and solve some equations using the quadratic formula. One thing I like to make sure I do when I'm using the quadratic formula is remember my ABCs. It's amazing how easy it is to just get these mixed up a little bit. So I like to start out by saying A is 6, B is negative 5, C is negative 4, remembering to take those negatives with us. Then I can substitute those into our equation. So I have x equals negative 5 plus or minus the square root of negative 5 squared minus 4 times 6 times negative 4 all over 2 times 6. So I get x equals 5 plus or minus the square root of 25 plus 4 times 4 is 16. So 6 is 96. I left all my notes in my office. I'm recording this as it's really snowy outside. All over 12. So I get x equals 5 plus or minus the square root of 121 over 12. Now 121 is really nice because it's a perfect square. So I get x equals 5 plus or minus 11 over 12. So x equals 5 plus 11 over 12. That means x is 16 over 12, which is 4/3. Always remember to simplify your fractions. Then I have x equals 5 minus 11 over 12. Well, x is negative 6 over 12, so x equals negative 1/2. So even though I used the quadratic formula, I still have rational x-intercepts. So a lot of people ask me, how should I know when to use the quadratic formula or another method? The quadratic formula always works. But I know for myself that when I factor by finding the factors of AC that add to B, it's faster for me. So let's try that with example 2. Okay, so what are the factors of AC, which is 4, that add up to negative 8? Well, there are none. There are no factors of 4 that add up to negative 8. So in this case, I could say, oh, I can complete the square, or I can use the quadratic formula. Because my leading coefficient isn't 1, that's going to make completing the square more fractiony, a little more complicated. So this is a perfect time to use the quadratic formula. Label my ABCs. So I have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so x equals negative 8 plus or minus the square root of 64 minus 16 all over 8. Well, 64 minus 16 is 48. So I have x equals negative 8 plus or minus the square root of 48 over 8. Well, I need to simplify that radical. 48 is 4 times 4 times 3, because 48 is 4 times 12. So I'm going to have 4 square root of 3. That's what that's going to simplify to. So I have negative 8 plus or minus 4 square root of 3 over 8. And I can simplify this, right? They all have a factor of 4. So x equals negative 2 plus or minus the square root of 3 over 2. They are my two x-intercepts. And if I want to separate those so I can see a little more clearly, I can. But they are both present in the first way. Let's talk about a very important part and special part of the quadratic formula, and that's what's under the radical. We call that the discriminant. The discriminant is b squared minus 4ac. And we can use the discriminant to determine both the number of solutions our quadratic is going to have, which would be the zeros or x-intercepts, and the type. So are they irrational, or complex? So if I have my discriminant is positive and a perfect square, for example, like 36 or 49 or 121, there's a bunch of them, I'm going to have two rational solutions. If my discriminant is positive and it's not a perfect square, then it's not going to simplify out to a constant, right? So I'm going to have two irrational solutions. If my discriminant is 0, I'm only going to have one real solution. That's what we call a double root. So if I had like x plus 2 squared, that's going to be something like if I have 2 plus or minus the square root of 0 over 2, well, that's really just 1. So we'd only have one real solution. And if my discriminant is negative, remember that's what's under the radical. So we're going to have two complex solutions. We're going to taking the square root of a negative number. And my solutions are actually going to be conjugates of each other. So fun fact. So let's take a look at these two examples and determine how many solutions they have and what type they are. So if I have a equals 6, b equals negative 1, and c equals negative 15, I have negative 1 squared minus 4 times 6 times negative 15. So that's going to be 1 plus 4 times 6 times 15. So I get 361. Well, that is not a perfect square. Let me double check that, but I'm pretty sure. Oh, it is a perfect square. Oh, wow, I failed. Okay. So the square root of 361 is actually 19 squared. Who knew? Fun fact. So we're going to have a positive perfect square, so we've got two rational solutions for this first example. We'll do the next example in orange. So I've got a equals 3, b equals negative 4, and c equals negative 5. I have negative 4 squared minus 4 times 3 times negative 5. Well, that's 16 plus 60, which is 76. Well, it's positive, but it's not a perfect square. The square root of 76 ends up being an irrational number. So we have two irrational solutions for this second example. Good to know. Next, let's find the point of intersection for two functions. So if I have f of x equals x squared plus 5x minus 3, this is a parabola because it's a quadratic function. And g of x equals 2x plus 1, this is a linear function. I want to find where they're both equal. Okay, so we're going to find the x value where they both are equivalent, and then we'll substitute that back in to find the y coordinates of where these two graphs intersect. So I have f of x equals g of x. That's going to be x squared plus 5x minus 3 equals 2x plus 1. We combine like terms. And because I'm working with a quadratic and that's something I can factor, I want to go ahead and get everything on the same side and have one side equal to 0. So now I look and I say, okay, what are the factors of AC that add up to B? Well, that's going to be 4 times negative 1. So I have x squared plus 4x minus 4 equals 0. And then I factor by grouping, remembering I don't like negative leading coefficients. X times x plus 4, negative 1 times x plus 4 equals 0. So I get x minus 1 times x plus 4 equals 0. So my x's are x equals 1, because I set both of these equal to 0, and x equals negative 4. Now, I need to find the y coordinates. I can do that by plugging back into either of my equations. I'm going to go ahead and plug back into g, because it's simpler to work with. It's a linear equation. 2 times 1 plus 1. So I have g of 1 equals 3. That means when x is 1, y is 3 is one of our intercept points. g of negative 4, that gives me 2 times negative 4 plus 1, which is going to give me negative 7. So when x is negative 4, y is negative 7. These are our 2 points of intersection. Why don't we go ahead and take a look at what the graph of this function would look like. So in red here we have our parabola, and in blue here we have g of x, and we can see that their 2 points of intersection are exactly what we found. When x is 1, y is 3. When x is negative 4, y is negative 7. So remember, it's always kind of good to envision what's going on with our functions. It's not always the case that we're going to have 2 solutions. If it touched just on like the vertex, we'd only have 1 solution. If it never crossed the graph of our parabola, we'd have no solutions. So it's not always going to be the case that you have 2 solutions. So it's always good to kind of visualize what's going on.